This is the Unit 3 review on quadrilaterals. The best way to go through this review is probably to pause the video at the beginning of each problem, work it out on your own, and then come back and watch how I do it. I'm going to move pretty quickly so we can get through these problems. These are just a sample of the types of problems you'll see, so make sure that you review those questions that you especially don't understand. So the first one we have is the square ABCD is an isosceles triangle. So right here, we have a square ABCD and a triangle isosceles triangle, and all these things are marked with congruent sides, and they're drawn to create this trapezoid. Now we want to know what is the measure of angle DCU. DCU is this whole angle from here all the way over to there. Well, we know part of it is 90 degrees, and then we need to know this angle BCU in order to find out the measure of the whole angle. Well, if this is an isosceles triangle, then we know, I'm going to erase this for just a second, we know that BCU is congruent to BUC, and we know this is a 90-degree angle, and all angles have to add up to equal 180 degrees. So if this is an isosceles right triangle, then we know each of these angles must be 45 degrees. So to find this whole angle from here all the way over, we just add those two together and we get 135 degrees. All right, Juanita's cutting a piece of construction paper in the shape of a parallelogram. So we know we're going to have a parallelogram, and we know that two opposite sides, so two of the opposite sides have 5n minus 6 and 3n minus 2. And then a third side measures 2n plus 3. We know opposite sides of a parallelogram are congruent, and so what are the lengths of two adjacent sides? So once we find out one side, each side, then we are going to add those two together. So first off, we're going to set 5n minus 6 equal to 3n minus 2 to solve for the length of this side. So we subtract 3n from both sides and add 6 to both sides. So we get 2n equals 4. Divide by 2, so n equals 2. Well, that tells us n, so now we just substitute that in, and so 5 times 2 minus 6. So this side is equal to 4. And this side is also equal to 4 because if we substitute that in, 3 times 2 is 6 minus 2 is 4, and we know that's where they're congruent. Now we need to find this side. So we do 2 times 4, or 2 times 2, excuse me, 2 times 2 plus 3, and 4 plus 3 equals 7. So we have a side of 4 and a side of 7. Now adjacent sides means the ones next to each other. So we have the two adjacent sides are 4 and 7. So if a corner of a rectangle is cut off to create a trapezoid, what is the value of x? Well, what are the sum of the angles of any quadrilateral equal to? Well, they're equal to 360 degrees, and we know this is 90 and 90, and then we have 45. So if we say 90 plus 45 is equal to 180, 225, and then we say 360 minus 225, and we would get 135 degrees. So in this one we have a rhombus. It's shown with its diagonals. Measure of angle MLO. So MLO, this whole angle right there is 112 degrees. And we want to find the measure of angle MLP. Well, MLP is just this section halfway. So MLP is just from here to here. Well, what do we know about a rhombus? We know that the diagonals bisect the angles. So that means this side is congruent to this angle. So if it's 112 degrees, all we have to do is say the measure of angle MLP is equal to 1/2 MLO. Angle MLO. So just divide 112 by 2, and we are going to get 56 degrees. If a carpenter cuts the corners off a rectangle to make this trapezoid, what is the value of x? Remember, with a trapezoid, we have two opposite sides that are parallel, or one pair of opposite sides that are parallel. And if you look, remember, this is our parallel lines cut by a transversal, and these would be considered same side interior angles. And what do we know about same side interior angles? We know they're supplementary, which means they add up to equal 180. So we take 9x plus 7x plus 4 is equal to 180. So we have 16x plus 4 equals 180. subtract 4 from both sides, so 16x equals 176. Divide by 16 and we get x is equal to 11. So kite ABCD represents a softball field that's being built. If AC equals 48 meters, so from here to here, that's 48 meters. What is the perimeter of the whole field? So we need to find AB and times it by 2, and we need to find AD and times it by 2. Why? Because we know in a kite that adjacent sides are congruent. So AB is congruent to BC, and AD is congruent to CD. So if we can find each of those, then we can find the whole perimeter. What else do we know about kites? We know these form a right angle, and they bisect each other. So that's congruent. So we can take that 48 and split it into 2 of 24 and 24. Oops. And I'm going to take a look at this triangle here, and I'm going to take a look at this triangle here. And so I've got one triangle, my green triangle, I'm just going to draw it this way, is 24, 32, and I need to find, this is a right angle, so that's going to be, I'm going to call it C, because C squared. And remember, we're going to use our Pythagorean theorem, which is a squared plus b squared equals c squared. Well, I could do this, and I could say 24 squared plus 32 squared is equal to c squared. And I could solve that in the Pythagorean theorem, and we would end up getting c is equal to 40. A quick way of knowing how to do that, remember our 3, 4, 5 right triangle? Well, if they're multiples of 3, 4, and 5, that's also true. So 3 times 8, so we're multiplying 3 times 8. This is 4 times 8, so this should be 5 times 8, because that's our 3, 4, 5 right triangle. So 5 times 8 is equal to 40. We're going to get the same thing. So 40 just gives us, 40 just gives us one side, which is this side right here, 40. Now, then we know this is 40. Well, now we need to find this. So let's look at this triangle here. So we've got another triangle, and we've got 24, we've got 18, and we're going to call this D. All right, we can do the same thing. Set up the Pythagorean theorem. Or I can say, are these multiples of 3, 4, 5? Well, 3 times 6 equals 18. 4 times 6 equals 24. So 5 times 6 would equal 30. And if you wanted to verify that on your calculator, 18 squared plus 24 squared equals D squared. We certainly could do that. 18 squared is 324. 24 squared is 576. And D squared. So 324 plus 576 is equal to 900. And we take the square root of both of those and we get D equals 30. So that's just a shortcut if you know 3, 4, 5, but you can always use the Pythagorean theorem. So then we know this is 30, and then we know this is 30. So what is the perimeter? That means all the way around. So I've got 30 plus 30 plus 40 plus 40, and that will give us 140 meters. All right, the diagonals of a parallelogram are congruent. So first off, we know trapezoids and kites are not parallelograms. So now we have to say rectangle or rhombus. Well, a rectangle is the only one where the diagonals are always congruent. In this case, what is the measure of angle ADC of the quadrilateral? ADC is this angle right here. Because this is an isosceles trapezoid, we know that base angles are congruent. So that would be 115 degrees. Here's a diagram of a plot of land, and she needs to know the length of each side so she can buy fencing. So we want to know the length of segment FJ. Well, if we draw a right triangle here, drop an altitude, then we know this is 24. This is a square of 24, and then we know this is 24. And we just need to find this section right here. Well, we can use the Pythagorean theorem. 30 squared equals 24 squared, we'll call that x, plus x squared. So 900 is equal to 24 squared is 576 plus x squared. Subtract 576 from both sides. X squared equals 324, and we take the square root of 324, and we get 18. So this length right here is 18, but to find all of FJ, we need to add those two together, and so that will give us 42 feet. Here's a proof. ABCD is a square. We want to prove that BD is congruent to AC. We want to prove the diagonals are congruent right there. And if you'll notice, as we walk through this proof, we get right angles are congruent. So what tells us that AB is congruent to BC, is congruent to CD, is congruent to DA? Well, it's based on what we know about squares. All sides of a square are congruent. That's how we know all 4 of those sides. And then that helps you prove side angle side and then the diagonals. Okay, in this problem, we've got to point out a few key words here so we understand so we can get the information we need. So we have a 15 by 23 meter garden and 2 sidewalks run diagonal of the square section. So it's telling us that this section right here is a square, and that's the diagonal of a square, and along the diagonal of a smaller rectangular section. So this is a rectangle. So we're going to use what we know about squares first. So if we know this is 15, these are all 15. So 15, and we know that is 15. That's going to help us a lot. If we know this is 15, then we know that this section right here, from here to here, is 8. And now we can just use a couple of things we know. First off, on this triangle right here, we can use the Pythagorean theorem. We can say 8 squared plus 15 squared is equal to, we'll call this C squared. So 64 plus 225 equals C squared. 289 equals C squared. Take the square root of both sides, so C equals 17. That gives us this length right here is 17. Now, one of the things that we know also is if this is an isosceles right triangle, that means these 2 angles are 45 degrees. And this is one of our special triangles. Do you remember the special triangle? If we have a 45-45 triangle, then x, x, and x radical 2 are the lengths of the sides. So we could use the Pythagorean theorem and figure that out, or we could just say, well, we have 15, 15, so this side has to be 15 radical 2. And then when we put that in our calculator and add them together, we get 15 times the square root of 2 is equal to approximately 21.2. So this is approximately 21.2. And then we want to know the lengths of the 2 sidewalks. So that means we say 21.2 plus 17 is going to give us 38.2 meters right there. Here's another one. We put 2 isosceles triangles so they share a base. So this is the base right here that they're sharing. And that's one of the diagonals of the isosceles triangle. And it shows us that the base of both triangles measures 80, so we've got 40 and 40. And what is the length of this shorter diagonal? So we're just going to be using our Pythagorean theorem or what we know about 3, 4, 5 right triangles, because I can see 40, 50, so I know that's going to be 30, because those are all multiples of 10. You can use your Pythagorean theorem to put that in, but I know that one's 10. Then the other one I can say, we'll call this A squared plus 40 squared plus 41 squared, equals 41 squared. So A squared plus 1600 is equal to 41 squared is equal to 1681. So A squared is equal to 81. Take the square root of both sides, so A equals 9. So I have 9 plus 30, and we add those together, and we're going to get 39 inches. Here's a parallelogram. Which angle measures are correct? We know opposite angles are congruent. So if this is, and consecutive or supplementary. So I can just label all these. I know this is 125, this is 125, this has to be 55, and this has to be 55. So what's true? X is 55, yes. W is 125, yes. No. Z is 125, no. And Z is 55. Those are the true ones. What is the value of P? This is the same thing. Opposite angles are congruent, so 4P plus 12 equals 36. Subtract 12 from both sides, so 4P equals 24. Divide by 4, so P equals 6. That's what it's asking for. And which concept can be used to prove that the diagonals of a parallelogram bisect each other? So when we're talking about, if we want to show that they bisect each other, we want to show that those are congruent and those are congruent. And so we want to show that these 2 triangles are congruent. Similar triangles aren't going to do it for us, and rectangles we haven't even talked about, those kind of things. So congruent triangles is the concept that we use to prove that diagonals bisect each other. And that is it. Hopefully that helps. If you have any questions, let me know. Make sure you review before you take the test. Take notes. You can use 1 page of notes, front and back, on any of your quizzes and tests. So take advantage of that and write down the things. It'll help you remember them, and then it also helps you remember formulas and things that you don't always want to have to keep stored in your brain. So good luck.